Classic way, and let's go a little bit about the partitioning. After that, I'll show some basics of several file systems. Show you how they look on the disk, and I'll show some stuff of that in DFSee as well. What you see running here is ECS 2.2 running the virtual box. As a matter of fact, I mentioned those USB sticks yesterday, and that it's able. The boot manager that's on there is able to boot several ISOs. What you see right over there, this is the contents of the memory stick that's plugged into the Mac. And you see there's a menu, file. I need my glasses to read the keyboard. It's getting worse every year. Oops. File. What you see there is that the first this used to work. The first two entries here are the ones that are visible. The rest is commented out. But you see here the first entry. Boot 3 does run DFSee, and select option blah blah blah. So this is going to be on the menu line, and it's going to boot by DFSee does ISO file, which you have to copy over to the memory stick. And you see the second one. It's part of Linux will use this ISO. And there's quite a few others here, like the Ultimate Boot CD and other stuff that you can put on there. And if you remove the command thing, not sure how it's never mind. But you can unconnect them and just make them visible on the menu, and then you can do other stuff on the same menu.
So when you plug it in into your regular machine, it comes up as a dot, like a regular drive. Where is that file?
Actually, if you go into this is more about VirtualBox than it is about. VirtualBox stuff. So if you go through, this is my development machine. Go to the settings, and you go to ports, USB. Then you can see that there's two types of memory sticks more or less registered. It's got some kind of filtering on the USB identification stuff that's in every USB device. And if you have got a new one, you just plug it into the Mac, and then you go right there, say plus. And then it will show whatever is plugged in, and you can click that one, and it will add it to the filter for this VirtualBox machine here. And then if you plug it in, it will actually capture it right away. So it will not be visible in the Mac, because it has been taken by a VM exclusively. And actually, if you do it while OS2 is running, you see just the usual stuff popping up, that it's detecting the drive, and that it's assigning drive level, and etc.
So inside of OS2, it comes up as like the C drive or whatever, and then it's just a fat file that you're editing. What's going on there with the file system?
Whatever is on the memory stick. And in this case, that's FAT16.
Right. So but this is the memory stick you create, right?
Yeah.
Yeah. Okay. So it has a fat.
File system. Yeah.
Okay.
And on the DCS system, is it actually going through the USB driver?
Yeah.
Okay, so
it's just USB, USB pass through. Works very well. So if you have to eject it, then you have to go into the VM and eject it there using the ECS stuff, and then after that, either one or two things can happen. Either it becomes visible in the Mac and you have to eject it there as well.
okay,
or it's gone all together now. You just pull it out.
all right.
I'm not sure exactly when one of the two happens. Sometimes it's one, sometimes the other. Okay, that's how it works. Let's close that. So there are a few virtual boxes. I also have a DOS version that just attaches to the DFSee ISO file, and if you just start this one, let's do it right away. I'll start it right over here, of course. Sorry. It's so fast, it's already up and running. This is DOS running now, and the DOS version of DFSee. And it has its own virtual disk with actually there's two disks here, you can see there are two disks, both the partitioned using NBR style. This is the one that's booted from. Actually, no, it's not even booted from it because I attached an ISO to it, so it's actually booting from CD-ROM. It's a virtual PC, but it has a CD attached virtually, and that's what it's booting from. Yeah. But it could also boot from this CD drive because FreeDOS is installed there as well. And this is the second disk, and you can see there's JS partition on that, and I could actually go into that using DFSee even while it's DOS. It's just like you start DFSee from a CD-ROM or. Okay. Let's get back to the presentation. Oh, of course, the same thing goes for the OS2 version. Just get out of that one. Directory, there's some files over there, you can see. And those are actually result files from the DFSdisk procedure that I mentioned yesterday, I think, which is a sort of an information gathering thing in DFSee that generates 5 or 6 files, which both in human readable and binary form describe most of the interesting stuff on the disk. And I use that a lot to get information from clients, and then you can actually load those files into DFSee, into a virtual disk, and then I can look at the disk almost as if I were on site. So that's great for support stuff. Actually, I could. This is let's see. This is from the machine itself, the OS2 virtual machine, but there's also a set of files here for my my Mac SSD thing. I can actually just enter on that. And we'll start DFSee. And we store those files into a virtual disk. You can see it happening here. And it will tell you where it came from. So this is the scope of the file. I made this a couple of days ago. And there you see the contents of the Mac disk actually. And it's just reading that from those files. But I could dig in here and everything is there except for the real data. All the boot sectors are there, the partitioning sectors are there. It's just the data that's missing. So this is a great tool for analyzing stuff, and analyzing problems, and testing recovery scripts and stuff like that. Okay, we'll get into that later. Let's go to the partitioning presentation. Okay, so the subject is partitioning, mainly the classic style of partitioning using NBR style partition tables. Most people are used to it. Also a little bit on the GPT partitioning, which is a new style that relieves you of a lot of the limitations of NBR partitioning regarding size and number of partitions and stuff like that. Other odd stuff about that. Okay, why would you use partitions? Well, there are a lot of reasons. Some of them still valid, some of them less so. Disks are getting bigger and bigger. Computers are getting faster. So some of the old reasons to use partitions maybe not applicable anymore, but a lot of times you want to keep things separate and be able to use this on other systems, or have different operating systems use the same information or not. So you like separate things. Although don't separate things too much, because if you divide a disk up in partitions, then you're stuck with the sizes you choose, more or less. If one of the partitions fills up, and you've got a Windows partition, for instance, then you've got a real problem. Even if you have a lot of free space in other partitions, it will not really help you keeping Windows running. So partitioning is not always good, and most operating systems and file systems are pretty good at managing even large, very large volumes these days. So, okay, another thing that used to be important, for instance, if you were using DFSee or FAT, you had to divide the disk up if it was larger than the limit for the file system. So FAT file systems cannot go over 2 gigabyte, classical ones. HDFS cannot go over 64 gigabyte, and there are a few more such limitations. And if your real disk is larger, you have to cut it up in parts, partitions. And of course, if you want to use multiple operating systems on the same system, the same disk, then each operating system is probably going to need its own partition most of the time. Some stuff can be installed into the same partition. Okay, and most operating systems do require partitioning, even when you only have a single partition on a disk. It still needs the administered data on the thing for a partition, with a few exceptions. And, one of those exceptions is called a large floppy, used on where the name came from, floppy disks, but also on USB sticks and stuff like that. That's one of the areas that Station has a problem with the FAT32 file system. That's very common on USB sticks, and if that's not partitioned, which is optional on Windows and Mac systems, then those sticks will be usable on Windows and Mac, but not on the Station, because it really needs a partition there to recognize and use the FAT32 file system. The problem with that is that if you get a stick handed over from a Windows user or a Mac user, you won't be able to do anything with it without modifying the stick, which is probably not what they want. Okay, then partitioning. On most PC systems, there will be NVR partitioning. Classic partition tables, and what I will do is divide the disk up into a maximum of 4 areas called the primary partitions, and one of those you can divide up further into logical partitions. And what you get then in that one extended container, as it's called, you can have a chain of logical partition, where each partition is its own little partition table. Then there are a few alternatives, like GPT that I already mentioned, which is GUID-based tables. The information in there, there's more information. It allows for larger sizes, and it's newer, so it provides for more information that's useful. There's also more redundancy, because the partition tables are larger and the area is replicated at the beginning and the end of the disk. So if one of those areas gets damaged, you can still get the information from the other area.
On the classic partition table, the way you have it presented here, it looks like there's no limit to the number of partitions on the device.
No, there's no real limit. That's true. I've seen people having 40, 50 partitions on a single disk. It's possible. Yeah. It's just sort of a linked list, a chain of partitions.
Does that work in the Station?
Oh yeah.
Oh, it's this piece.
Some of the partitioning tools have arbitrary limits on how many partitions they will allow.
Yeah.
Actually, I think the limit in DFSee is something like 1,000. I think I'm going to pre-allocate a table for 1,000 partitions.
Yeah.
I think initially when I started this out, I started with something like 50, and then one of my clients ran over that. I don't see my 50-50 partition.
Yeah.
Okay, the GUI thing is unlimited because it's sort of an array of information on each partition, and the size of the total area is configurable. So and actually, if you've got a GPT system for backward compatibility, there's also an MBR. So the MBR will just have a single partition defined with a special type, EE, and it has a guard partition in it that spans the whole disk. And then the next sector will be the start of the real GPT definitions. We'll look at that later.
You know us to get to those?
No. DFSee can show them at the moment. You cannot manipulate them, so you cannot create new partitions and stuff like that. But you can, if you look at the Mac disk, well, we looked at just a moment ago. You'll see the partitions inside that guard partition. There's some discussions going whether we could and how we could support GPT partitioning.
Yeah.
Because some Windows systems come partition this way, and all Macs come partition this way. It's more flexible. It's also a part of the UEFI specification that the newer BIOS stuff is, so that includes GPT partitioning. It's part of the same specification as
Can you use GPT without UEFI? I mean, it's direct. Can you have one without the other, or?
Yes, yes.
Because with UEFI we have a problem in general.
Yes. Yeah.
If there's no compatibility layer anymore.
Exactly. Most of those will have a compatibility layer, so there will be an all-style BIOS available, so you will be able to boot. But it's not just the partition itself; it's also the boot sequence is different on those systems usually, because the boot code will be in specific GPT system areas, and not. They will not be part of the operating system. It will be sort of a chain loading program before that.
But from practical view, there are systems out on the market that still have the compatibility layer, but are already using GPT.
Partitioning, yeah, yeah.
Okay.
I think I've even seen systems that don't even have the UEFI BIOS, but still use the GPT style partitioning.
Okay.
It's not really.
So that's even more urgent. In other words, work on GPT.
You can always repartition. Yeah. And apart from the GUI, you got some other stuff. There's Macintosh all-style partitioning that looks a little bit like the GUI GPT, but it's different. And then all Unix and mainframe stuff, they all have their own mechanisms and layouts for partitioning one way or the other. Okay, then NVR partitioning classic. Each disk has an NVR. There's boot code in there, which is important because the BIOS will usually go either to the first disk or on modern BIOSes, so you can usually select which disk will try to boot from. But there's some boot code in there, and that will interpret the partition table, and then it will transfer control to the boot code that's in that partition boot segment. And on GPT, as I mentioned, it will be slightly different. If you do it the official way, we'll go through GPT, chain loading stuff. Actually, the way to program that, you have to create a program specifically for UEFI. So it's operating system agnostic, more or less. So it's not bound to any operating system, it's bound to the UEFI specifications. And that will eventually then start your operating system. And there's lots of stuff tied into that specification, like things like the security and trusted systems, blah blah, Microsoft stuff. Mac also goes with it. To make sure that you're booting something that is trusted. Okay, then on the NPR thing, root code will be in the active partition usually, or it would be in root management. This is also different. Your BIOS may list the disks that you have in your system if you have more than one. May list it in a different order than your operating system may later, because they could have different mechanisms for enumerating disks, and that sometimes causes problems with drive lettering or letting you pick the wrong disk to wipe clean or something. So be aware of that. Okay, this is what it looks like. This is the total disk, and there's 3 primary areas here. First one, second one, this is the third one. And the third one is divided up in 3 logical partitions. This is the table looking to it. It just has a start and an end and a size information. I don't think I'll just go into all the gory details, but this is the information that's in there. Actually, the start and the size stuff is coded there twice. One time in the classical way, the old way was called CHS and RESIC. That's the old physical disk layout where you have cylinders and tracks on one cylinder and multiple letters and a read-write head for every letter, and those values are coded into the partition table. There's also a linear value coded there, so it says something like this partition will start at sector such and such, and it's so many sectors in size. And there's a problem with the CSS stuff, and that it's limited in size, extremely limited. It can only describe up to 1024 cylinders, and depending on what the geometry is, that's just a couple of gigabytes in size. Oops.
Is that largely ignored these days? CHS stuff?
Yes and no. Unfortunately, it should have been. It should have been ignored about 15, 20 years ago. Most things like Linux and other operating systems haven't been using CHS for ages, but DOS and Windows have in the beginning time, and OS2 as well.
Same is true for hardware.
Sorry?
Same is true for hardware. SCSI drives never use CHS.
Yeah. The problem is that the information is there, and tools tend to use it and check it, and if it's not consistent with the other information that's there, they'll give you a warning, or worse, if you've got things like partition matching. If something seems inconsistent to it, it will refuse to do anything with your disk. And some operating systems, especially the older ones like Windows 98 or even older stuff in DOS and the earlier version of OS2, would not boot if the CSS information was inconsistent. It would simply fail to boot, because they used some of that information to find other stuff that they could have found by using the other information that's also there, but they just didn't. So yes and no.
So it's alternative to information. The LDA is alternative to this.
Yeah, if everybody would have started using that 20 years ago, it would have a lot less problems with geometry issues with the system. Because the geometry really, what it says is something like there are some conventions on what boundaries you're going to start and end with partitions. And those rules are not really written in stone, unfortunately. And some partition tools or other stuff will check upon that, and if they're not correct, they'll give you warnings or they'll give you errors or whatever. And if you change your geometry, which is really arbitrary, it doesn't make any sense. But if you change that and you create new partitions, they will be on different boundaries. So you can end up with a mixed system where some of the partitions are aligned to geometry A and some other partitions are aligned to geometry B, which is not really a problem, but tools will complain about it. So it's just a pain in the neck.
So line means you always have to fill up the full track. You cannot fill up.
Usually, yeah. If you have primary partitions, then it has to start at the first head on the first track, and if you got usually you have to spare room, one track spare to put in the partition table and stuff like that. Lots of conventions that adhere to it, and it's not really a a very well written out specification. There's a lot of rules, so they're a little bit soft. Okay, each partition table is 4 entries. As I mentioned, there are 4 primary partitions, and then one of them can be divided up further, and then every of those logical partitions will have its own table. Partitions have a type, which is a single byte, so there's a value for instance, installable file systems all have type 7. The FAT file system has type 6, and lots of others. And you can, there's a mechanism to hide partitions by changing the value. And it used to be a problem using some boot managers that if partitions are hidden, then some operating systems will not see those partitions at all and will not boot and stuff like that. And usually there can only be one primary that's really visible to the operating system. For instance, DOS would not boot on the system if there were 2 primaries that were both visible to it. So that's why you would have to need the hidden feature to select between which of the partitions you want to use to boot. But these days most operating systems don't really care if partitions are visible or not visible. They don't really look at that hidden bit anymore. And the BIOS will only boot into primary partitions, so you cannot really boot a logical partition directly from the BIOS. If you want to do that, which is quite possible and most of them are used actually, you're going to need some extra software called Boot Manager, which will be booted by the operating system that will pick and find your operating system and boot them.
Go the wrong way again.
Okay, so this is what it looks like. The table describes the start and the end of each of those areas. Something more about the information. So this is the linear offset. It's in the partition table. And for the primary partitions, it will be the offset from the start of the disk. So for each of the partitions, this will be the offset. And the other value will be the size. So the size for each of those areas will be the table. And this information is all in this MBR sector, which is the very first sector of disk. If you got logical, it's a bit more complicated. There will be an offset here, which is in the MBR, and it's the start of the extended container, this is called, and that also has a size. And in there will be, on each logical, there will be an EBR, which is called extended boot record with a partition table, and it has an offset to this first partition, the size, and then on the second one, same thing, except that the offset that will be there for this partition will be from the start of this, where this partition table is. But the offset to the next one, because all those things are chained, are always from the start of this container. So see this one, this one, this one. Point to the location of the next logical partition. Yes.
It would help me to visualize this if you could explain the term offset, what that means in physical terms.
That's just the distance from the start of the disk to where a partition starts.
Measured how? In tracks?
Sectors.
In sectors?
Well, yeah, that depends where you're looking at, but because again, the same information is coded in 2 different ways. Linear, so that's just a number of sectors,
yes.
And the other one is in CSS values, if applicable. But usually on the disk we use these days, that CSS values will be maxed out anyway, because they cannot describe those huge sizes anymore. So.
Okay, so the offset refers to the number of the sector on which that next group of data starts.
Yes, and for primary partitions, the anchor point will be the start of the disk, so
yes.
Sector 0. And for the logicals, the anchor point will be the start of this container.
Okay.
So to find the real offset for a logical partition, you have to add up this value, this offset where this thing starts, and add the second one to it, and then you know where.
Plus the size, then.
Sorry?
It's the starting point plus the size of the one before it.
No,
No.
No.
No?
No.
that's what makes it interesting. It's a little odd.
Yeah, it's a complicated.
You sum up
It's more
all
complicated than it needs to be, but it's it's the way it is.
Yeah, is there
Well, if
any
they're-
history as to why they chose to do that? Is there any history why they chose to do the offsets that way?
No.
Or is it just because?
Yeah. No idea. It started out in the DOS when DOS started using partitions on the disks getting large, because originally the disk was something like 5 megabytes or something.
Sure.
At some point they were getting large and they needed partitions. And then just like the memory stuff, they said, okay, all everybody's going to need is maybe 4 partitions on the disk, and then at some point that was not enough, and then they invented something new.
Yeah.
That's the way it goes.
Isn't it possible for the logicals to get out of order eventually by deleting partitions and recreating them in a different order?
Well,
Yes.
to find out
So that has more
It
interest.
depends on your tooling. There's some conventions like stuff. If you got all the logicals, they will have to chain, and usually the chaining, so they're pointing to each other, is in order of their position on the disk. However, because the information is all there, you could also link back to a logical partition. So if there's a hole in there and you create a new partition, it could just point from the last one and just point it back into the
Right,
hole
yeah,
and create a new partition there.
And you have
And actually,
negative-
some Linux partitioners do that. And most other tools and operating systems will choke on that and will say, okay, this is totally
Yeah, it
broken,
doesn't work,
we'll not use this disk. So yeah, it can get messed up pretty much.
So can you have negative offsets? Negative values for the offset, or is the offset always positive?
Well, because the offset is from the start of the container here, if you make it from this one, you could put an offset in there that's something like this, and it will point right there. So it's not a negative offset because it all relates to this position.
the math all,
Really be
yeah.
negative.
The math works no matter what you calculate your base and your offset is. It's just a convention.
Yeah.
And what happens is certain partitioning tools says, wait a minute, this doesn't look what I would create if it's perfectly logically consistent, but it doesn't look like what that tool would create, therefore it assumes that there's something wrong.
Yeah. Well, if you find stuff like that, then DFSee will give you warnings about it. It says something like backward linking, and there's a cleanup command in the menu and also as a command that will actually rewrite all those tables to make it a linear chain of partitions again. Okay. So this is what it looks like more or less for each partition. So there will be an offset and a size, and an offset for a partition and a size, etc., etc. And in each partition table for logical, you'll find 2 things. The first one is the offset from that point to the actual partition where a file system is for the logical partition. And the second entry, that's what we call the pointer, the offset to the next logical. And only on the last one, you'll see that there will only be an entry for the partition itself because there's no link to yet another logical. So that the last partition table will only have a single entry, while all the others will have 2. One for the partition itself and one for the link to the next one.
Question, please. What are the values? They're expressed in what form here?
Well, same as with the primary partition tables, they're expressed as an offset, so how far...
A number, what kind of a number? These are all...
How many sectors?
No.
Well, there are numbers in sectors, and the size of those numbers are 32 bits, so you can address up to, if you're addressing sectors there, you can go into 4 gigabyte.
Sector.
2 point some gigabytes.
2 terabyte.
That's just the linear value. The other value is CHS.
Yeah, and that's maxed out way
Yeah,
before this.
but that's just got special values in it for anything large.
Okay, then apart from the actual tables, at some point in the OS2 development history, IBM decided that they lacked some information there that would like to have some more flexibility in several areas. One of them being assigning drive letters freely, because back from the old DOS days and also Windows and stuff like that, there was an algorithm that would actually assign drive letters to partitions based on their position on the disk, and whether it be primary or logical or whatever. And everybody adhered more or less to the same rules, so drive letters would more or less stay the same between operating systems. But it was very inflexible and could lead to errors. So one of the reasons they added more information is that they wanted to assign specific drive letters to specific partitions freely and be able to change those if you want. Windows had the same problem, so Windows NT or later had also made this to do that, but instead of putting it on the disk in an extension to the partition tables, as IBM chose to do, they decided to put it into their own operating system administration, and they put it in the registry, where else everything's in the registry in Windows. So on Windows NT and others, including Windows 7 and 8, you can still assign drive letters to partitions, but they will be registered in a different place. Meaning that if you go 2 or 3 Windows installations on the same disk, they may use different drive letters for the same partitions, because it's just an administration internally to Windows. With LVM, IBM introduced an addition to the partition tables, more or less, in another sector, closely related to either an MBR or an EBR, called the drive letter assignment table, DLAT. And that adds some information about the partition, like a name, a readable name, a drive letter, and some other stuff. And each DLAT each table, each DLAT table describes a single volume. And there's some more features that can be implemented using that. One of them is that there can be multiple physical partitions, so that really never took off the way they intended, I guess, because the flexibility offered by that was there in OS2. If you use a classical JFS system and your partition fills up, or your volume fills up, you can just create a new partition and say, okay, I want to add this new physical partition to this same volume, and LVM will do that for you. So you have a single volume that may consist of 2 or 3 or 4 physical partitions.
You could. I was wondering if you did that, you can't like back out of that, right?
No. That's a problem. They more or less stopped developing at that point. What they intended to do, and never got into doing, is having software and tools available to manipulate that stuff, and not only expand on the size, but also reduce it. So it's okay, it's not this extra partition anymore, then just move all the data into that one and then get rid of it. But that never got implemented. The only thing you can do is expand, and because those partitions could be on multiple disks. That's one of the advantages. So you could have a single volume on a system that have maybe 4 disks, one partition on each disk, and just see it as a single volume. That's one of the advantages that they used for on Warp Server for e-business, for instance. That was one method of getting large volumes with relatively small disks.
But adding up all these partitions, you still have the limits of the file system to...
No, the file system is still limited to whatever...
So maybe that was the reason, because we have so big hard drives today that you don't need multiple partitions.
No, you don't need it for that, that's true. And also you got a nightmare if, for instance, if you have those 4 disks, which is all one volume, if one of those disks goes bad, your whole volume is gone, because the single system.
Yeah, right, because the tools weren't they were not per partition, they were per volume.
Mm-hmm.
So you really didn't have discrete backup and restore.
Yeah, and if you have third-party tools or other tools that are not aware of the LVM information, it can very easily break. So
yeah, in hindsight, it would have been much better if they'd done something like TVS and integrate that. Because that way your partitions, while they're logically together, they're still functionally separate partitions, which we manage separately, fixed separately, and all the whole bit.
Yeah, there are lots of There are better ways to do it, but this is what they chose, and this is what we're stuck with at the moment. What I would recommend is never to use this anymore. Actually, since we have bootable JFS, which does not support this mechanism really, I think.
No, it does for data volumes, it just doesn't do it for boot.
Yeah, you just can't boot from it, but I just wouldn't use it. This whole mechanism is more or less tied to the system type 35, which is called an LVM volume. If you use LVM to create partitions, you'll notice that you'll have to choose somewhere between a compatibility thing or an LVM thing. An LVM is type 35, and actually the only thing really using that is the JFS file system, and you can still do that. If you choose compatibility, it will be some of the other types, like the classical installable file system 07, which you can put into an HPFS file system or a JFS, bootable JFS file system, or it can be a type 6 for a FAT file system, or something like 0C for a FAT32, stuff like that. Because you need extra information to chain all those separate partitions into a large volume, there's extra information that goes into LVM style partitions. But since it's prone to damage to the partitioning information in there, I would not recommend using it. It's a bit fragile.
Yeah.
And there's an LVM on Linux, is that unrelated to those? Totally different? Okay.
It's called the logical volume manager because they're managing volumes, but who isn't?
Yeah.
Actually,
It's not related at all.
my recollection is that LVM came out of a free source that was released and originally came from AIX.
Yes, that's right.
And in some ways it's similar, but the difference is on the AIX we're able to deal with strips rather than partitions.
Yeah,
so everything's a little different.
Yeah, actually there's a close tie with JFS as well. That also came from AIX.
Exactly.
And one of the things that LVM also does in that area is that it takes some of the administration stuff out of the file system and puts it into LVM control, like bad block administration and reallocation, stuff like that. So there's an area on that extra information that describes where the bad blocks are. And JFS checklist is aware of that information and stuff like that. But, well, same as with the multiple partition volumes that never matured really to the point that they had designed it to.
So when you're creating a partition, there's that question it asks about advanced or not. That's the thing where it puts that special type in?
Yeah.
It has a special type, and then apart from that table at the start with LVM information, it will also put an area at the end, which is actually larger. It's up to a cylinder in size, a few megabytes, and it has some duplicate information for redundancy that you can recover from the stuff. And it also has areas there to administer bad sectors and stuff like that.
And if you choose the non-advanced option, you can still format the partition as JFS?
Yes, as long as you're using the bootable JFS.
Right.
So
You use any JFS.
Well, no. JFS could always go on any site type 7 or type 35 partition.
yes, but I think it's meaning the other way around. You choose compatibility and then format it as JFS.
You could do that, yes?
Well, you couldn't with the old JFS, I think. It would refuse to format it. If it was the
They would
You're
format.
right. For a long time, I don't.
It would always,
It works all that.
it would always
The only
format
thing is
either
if you want
type.
to do the scanning stuff, you have to use LVM volume
35.
If you use compatibility.
Because
I'm going to have to go test that because I can haul out an old JFS IFS and see, but I don't recall it requiring a type 35 to format JFS. It just wasn't booted.
I guess the reason I'm asking is so there's no real reason to use that advanced feature.
no.
Not for us.
Because you can still get the JFS without it.
Right.
Yeah.
Okay.
You always use it this way.
Yeah, yeah. I mean, I usually choose the advanced because I didn't really understand what I thought you had to have JFS.
Yep, right.
So the data,
Okay, so a little more half an hour.
But a few years back, the documentation that was being passed out for ECS installs was always make the volumes LVM volumes. Always, when you're partitioning a disk, always make them LVMs.
No.
No.
I have it. It's in writing.
You're probably
I
mixing
did
up
this.
something. There's the thing compatibility volume or LVM type volume, that's one thing. What they probably mean at some point is that if you want to use equal-station with the disk and partitions, you have to have LVM information on it. That doesn't mean that the partitions in there are of the LVM type. It's just that each partition, even the compatibility ones, have some level of added LVM information that's being used by LVM to display proper names and stuff like that and assign drive letters. That's always there for compatibility and for the other type. But if you want to use volume spanning thing, so multiple partition in single volume, then you have to use a special LVM type partition. So that's something, that's another layer of complexity that you don't want to get into, I think.
Okay, so I'm thinking about the issue. Okay, so I'm going to bring up some new hard drives now. I'm going to use DFSee to partition them.
Yeah.
Do I want them, so what choices do I need to make when DFSee is partitioning them?
DFSee doesn't use the term compatibility or LVM type, it just has a whole list of possible partition types that you want to use. And it's probably going to be an installable file system for JFS or something else for 532.
Even before we get to that, I'm going to put, I don't know where I'm going to put, you know, ECS, I'm going to have DOS, I'm going to have Windows XP, I'm going to have Linux. So what kind of volumes do I, when I'm creating the partitions, what choices do I need to make so it could be any of these?
Have you even looked at DFSee to see the terms it uses?
That's what I'm asking.
You should read. There's a whole section called DFSee terms. The problem is he's using the terms and you don't understand the definitions yet because you haven't read the definitions for him. And we're going to go circular until they're just words until you read the definitions.
Yeah, you just have to create partitions the way you would like to have them, either primary or logical or both, depending on how many you have.
Yeah, well, he's
And the only thing you have to consider is that if equal-station is part of what will be on the disk, it's probably wise to add LVM information to each of those partitions right from the start, so that ECS, when you start installing, will recognize those partitions properly.
And one other thing is Windows, I believe, requires a primary partition to boot from if you're planning to go. Right? Is that right or not?
Yes and no.
I mean, for his
There's a
purpose.
small portion of Windows that's initially booted that has to be on the primary partition.
Okay, so he would need one of those if he wants to install Windows.
Yes.
Yes, okay.
Yeah. And usually, to keep things simple, I just create something like whatever these days, 20 or 40 gigabytes of primary partition. Just put Windows in there. Then everything is in that same container, the same partition. But there are also people that say, okay, no, I just make a small DOS partition, a couple of gigabytes big, and I'll boot from that, and then I'll put Windows in one or more other logical partitions.
And you can do that? Windows will install those logical partitions?
Depending on your load, depending on your seat, depending on where you got your Windows.
Exactly. You could have a single DOS partition with DOS installed in it called C, and there would be some files for Windows as well, that booted from a D or E or whatever logical partition. It's all possible.
Yeah, retail Windows, you can basically install it wherever you want, and you can also use it and install without destroying what you already have. Preloads, the rules are very different.
Okay, let's continue. Well, this is why one of the reasons they did it, that as expensive as possible, you could add it, but only with the classical JFS on OS2. One large volume will disks, drive letter and signs don't change, that's not found. Sometimes if you got external disk, for instance, USB thing, you got the LVM information on there. Either choose to assign a specific drive letter to it, and it will have that same drive letter on every system, as long as that drive letter is available on that system. You can also put an asterisk in the drive letter field for those, star, and what it will do then is it will just assign the first available drive letter. On my system, if I plug in, it will usually get the C drive letter because I never use C for OS2. So C is available and it will assign that to the first USB thing I plug in. Okay, this is what it looks like for a compatibility volume. So one disk with primary partition there or logical in this case. There will be an EBR with the partition table, and in that same track, just a few sectors ahead of it, or past it, there will be an LVM information sector, VLAT, directly before the actual partition with the partition boot sector. So there's additional sector here that together with this one and this one describes the partition. And it has the drive letter, and it has the scheduled names, it has a flag to signal whether it's on the boot manager menu, stuff like that.
So that EBR mechanism allowed for that gap there, so you could slide stuff
in the old conventions, the EBR area would be one track, so usually there would be something like 63 sectors or something. And the EBR itself would be at the first one, and the LVM sector is at the last one. So there will be a gap in between. And the same goes for the MBR area as well. There's MBR at 0, and the first primary will start at 64 or something, and then the LVM information will be at 63. Yes.
If there's more or less than 63 sectors per track, though, that moves around, doesn't it?
Yeah.
Oh, yeah.
So the position of this sector depends on the geometry. That's one of the things I mentioned. Geometry is really not significant, but on the other hand it is, because that will determine where the stuff will end up. And for instance, if you change geometry and you create new positions, it may create a new sector somewhere over there, and then there will be two that are conflicting. And one of them is not valid anymore because it's not corresponding to the current geometry. But still, if tools are looking in specific positions, so what DFSee does, if you start up, it will actually scan the first 300 or 400 sectors to see if there's an LVM sector or see if there are multiples. And then it will give you a warning if there are multiples, because then there's a problem with your disk partitioning probably, or something you're not aware of.
And at some point, and at some point in time,
It's get interesting.
at some point in time, DFSee will probably have the ability to replicate that LVM sector, because there is software that assumes that LVM data will be at a certain sector regardless.
Yeah, 63 usually. Yeah, which doesn't.
When you scan for this, is there some sort of signature that enables you to identify it, or
Yeah.
just?
Yeah. Yeah, that's a unique signature at the start of every sector.
Not only that, it's very well protected. It's got good checksum data and all that stuff that would be nice to have elsewhere.
Yeah. Actually, one of the advantages of using those LVM type partitions is that most of the information is duplicated, and if for some reason you have the partition deleted and the information deleted, DFSee is able to find that duplicate information at the end of the partition and actually recreate the whole thing from there. So if you create the partition new, recover it, it will still have the original names and stuff like that, and the drive letter assignments, everything will still be there. That's a small advantage, and I don't think it outweighs the disadvantages of using that LVM type 35. Okay, this was a simple one. There's more. This is the type 35, so what you see there is the same thing. There's the EBR, there's the LVM info thing, and the BBR, so this information all together. But then, apart from the partition data, which is in the partition itself, at the end of it there will be what they call the LVM signature area with the bad block relocation stuff and drive linking information, and that's a couple of megabytes in size.
That's if it's a type, whatever that is, 35.
Yeah, type 35, yeah. And all the other types are called compatibility.
And do other OSs like this?
No.
They might wipe, not this internal stuff, but that other stuff, the first LVM green thing.
This one.
Like, does Windows observe that and not touch it? Or it can cream it, or?
Well, by convention, they will leave it alone. But
Okay.
Maybe.
no guarantees.
Maybe.
It's like the Geneva Convention, huh?
Well, for instance, in the same area, if you go into the MBR stuff and start with the disk, this same area that's sort of reserved is also used by the airboot manager, for instance, to install its code. But it's small enough to allow for room for the LVM.
Well, Airboot's okay because it does respect it, because it knows that it should be there, so it knows not to overwrite.
But there's
But to give you an example, I have a friend who insists on using partition magic for partitioning. And he also insists on using FixPack 10 for some of his disk, for some of his OS2 installed. He's eccentric. And he shows up at our SCOAG meeting with a disk that a drive that we had installed for him and no longer booted, for the obvious reason. He added 6 partitions using partition magic. And it promptly wiped out that data, because it writes zeros there, or FCs there, I forget why.
Yeah, there's more possible problems with using other tools. One of the things is that, let's go back to the previous one. If you look at this gap, some of the Linux partition tools thought, okay, that's all wasted space, let's just put the EBR and the partition boot record close to each other and reduce that gap to 0. It's possible, I mean, the partition still works and is visible, but there's no room for LVM anymore. So, and actually if you do that and just use the LVM program, it will just say, okay, the geometry is something like 63 sectors, so I'll just put the LVM information 63 sectors past the EBR, which is in the middle of your data. And it will do that.
Sure, right out.
It usually doesn't do much harm, but you never know what you're going to overwrite, but it will be inside of your Linux partition. And probably hurting something. And so DFSee also gives you a warning about that. It will say, okay, there's no room for LVM information. And if you use DFSee, it will not create it, but the LVM program itself, the recomstation, will.
So you get into that trouble if you allow Linux to create your partitions for you?
Yeah.
But then sometimes even if you don't allow Linux to create the partition,
Yeah.
start overlaps, do that.
Yeah, some of the Linux installers actually just install to a logical partition that you already created there because you know how you want it. But we'll just say, okay, well, we never know. We'll just create it new and rewrite the partition table so we know it's Linux compatible. But at the same point, they probably move the EBR to a different location because they think that's more convenient for them, overriding LVM information in the process. So that's why I would stay away from most Linux tools because you never know exactly what they're going to do because they're not very aware of, well, maybe aware, but they're not.
They don't care.
They don't really care about operating systems.
On this system, I created the partition with, I can install Linux into it.
Most of the distribution will actually use it. If you create it before with DFSee or something else and everything is the way you want it to be, and if you use the installer in advanced mode or something, you can just say, okay, I want to install it to that partition and I don't want to touch anything. Most of them will do it, but some don't.
Even some in advanced mode, they muck it up. Well, you can understand their point of view. Their target market is folks that are not much smarter than Windows users, and they don't understand partition. So they just do something that'll work.
So what's the solution for installing Linux? Are there certain distributions you can install it?
Simple. Don't use the Linux, just what he said. And he said, don't use the Linux partitioning tools.
Yeah.
And when you're installing...
Try to avoid having Linux doing anything to the disk except installing their code.
Okay, so there's a differentiation and you have a choice, like telling it not to format
on
it.
most distributions you have a choice. On some distributions it's hard to find, on some distributions it's simply not there.
So don't use that distribution.
Just install the way they want to install.
And how would you know beforehand?
No.
Ask.
You have to
Who would we ask?
Well, you can know beforehand, like Red Hat, for example, and the things that are copies of that, it's pretty clear when you're installing, you better pay attention, but you can make those choices and say you want the advanced option, you can go in and do all this stuff. It's pretty clear.
It comes up in the installation process.
Yeah. And then it'll just use the partition that's in place already and not do any of these things we're discussing.
David, what Jan is saying and what we've seen is every now and then there's a couple of Linux installations, because they're all a little different, that will actually, in advanced mode, rewrite the partition table because it knows better than you.
No, I've never had
Even
that happen.
advanced, no.
Yeah, I have a few times.
I would suspect most of those have gotten changed by now because people have got to complain because it screws up multi-boots.
Are there any recommendations, Linux, that works okay?
I use CentOS, that's very nice, it's free and it's a copy of
I've
Red
used
Hat.
several like ZooC or Ubuntu. They usually work well enough. I don't do much with Linux.
Could this happen from version to version that it changes?
Oh yeah.
Okay.
If possible, try to stay away from the very latest Grub implementations. That's Boot Manager. There's a new generation, Grub 2, I think it's called. It's even more complex than the previous version, and it's less compatible with other operating systems. It's very tricky. It doesn't respond well to moving stuff, because actually when configuring Grub, the boot manager on Linux, it will find stuff that it needs to boot, and it will record those exact physical locations into its own administration. And when you start moving stuff, it does that up, and Linux will fail to boot and stuff like that.
So they go the Windows way then?
Yeah, more or less. They just assume we own the world and we'll just put it in our administration and everything will be fine. They don't really care about anything else outside.
They
They're
really
both
don't deal with multiple OSs.
Okay, let's continue,
Also-
otherwise we'll run out of
Okay, yeah.
time too quickly. LVM information used by compatibility and other ones. Drive level assignment table, that's the IBM name. There's some generic info in there, like disk geometry. That's one of the things you may want to be aware of if you clone a smaller disk to a larger one using DFSee. So you do a disk-to-disk clone, or with any other tool, doesn't really matter. It will clone anything, everything that's on the disk, including this LVM information. And because the disk geometry is in there, it means that if you look at that disk again with DFSee after cloning, if when you clone the 100 gig to 500 gig, it will still say, okay, this is a 100 gig drive, because that's what's in the LVM information. And for DFSee, the LVM information is leading with regards to geometry and disk size. So it doesn't really listen to what the operating system says it is, because the operating system probably knows it's a 500 gig drive. It will still say, okay, now this is 100 gig. So what you have to do at that point to make the extra space really available, because that's probably why you clone it to a larger disk, you have to go into the LVM part of the DFSee menu and set a new geometry that is for the full size, and then write it back. There's a description of that somewhere in the help how to do that.
So you figure out the details so that we don't have to get out our calculator?
Yeah.
Okay.
So that's automated into
Yeah, what you actually do is you tell DFSee through the menu, do not use the LVM information for the size, but use the operating system information. And that will set a new geometry that's for the disk. And then you tell it to write that information into all the LVM sectors that are on the disk, which could be dozens of them. And all of them have to be consistent.
The menu entry called set LVMGO to DFSee logical geo.
Sorry?
I'm just looking at
Yeah.
DFSee. Set LVMGO to DFSee LVM.
Exactly.
Yeah.
And before you do that, you have to make sure that, I think that's in the edit menu somewhere,
Yeah.
where it says to use or not use content space sniffing or something.
Ooh.
I think it's in the edit menu. Because that's what I mentioned yesterday. By default, we will look at the partition tables and LVM information to determine what geometry to use and what the size will be.
And you tell it not to do that?
Well, usually the result will be the same because
No, no, what I mean in this case you're describing where you...
After
Yeah.
you've done a resize.
yeah, then you have to exactly. Okay. This is the extra information that's in the signature area at the end of the partition. That's then going to go into all the details there. That's that log relocation and drive link data. Okay, this is what it looks like again for primary partitions. So you see an NVR with the LVM at the end of the first track, and the gap in between them could be anything there. Usually it's empty, but it could be a wood vanisher or something. And then the primary partition, and here another partition with LVM signature data. So this is an LVM type partition, and this is a compatibility. This is what the whole thing looks like then if you got multiples. NVR here with the table at the end of the first track, then there will be some primary partitions. And all those primary partitions will be described in the same sector. So one of those tables can describe up to 4 partitions, just like the partition table itself in the NVR.
Doesn't that also contain the disk name?
Sorry?
Doesn't that VLAN also contain the disk name?
Yeah, this name.
Yeah.
Yeah. This name, and there's some checksums in there as well,
Yeah,
and
yeah.
geometry and stuff like that. Compatibility volume, primary, LVM type, primary with signature area, and then the same thing again for logicals, with each has an EBR, and with every EBR there's a DOIT associated with it, the logical, and same thing again with a JFS type partition.
Question, you're not talking about HPFS anymore, is the new installs are all...
HPFS is just one of those compatibility type of things. It's an installable file system, can go into a type 07.
HPFS is what you put inside the partition.
Yeah.
It's not the partition itself.
Exactly. In this data area will hold a file system that could be FAT, NTFS, HPFS, JFS, whatever. Except that with integration with this stuff, you really need JFS because that's aware of the extra information that's there, the other way around. LVM is aware of JFS. Okay, I think I'll skip this. It's not really that important anymore, but there are some limitations with it. And as I mentioned before, you'll get some warnings and some tools will complain, but usually it's not a big problem. The only thing that's being influenced by CHS is where things are positioned, and that may cause you problems once in a while. This is the major limit. There's another limit for OS2, by the way, also a cylinder limit. But in this CHS thing, there were 10 bits reserved for the cylinder number, which restricts you to this number, 1024. In OS2, in the kernel and on some device drivers, there's also a limit that cylinder number should be a maximum of 16 bits, which restricts you to 64K, 65,000 cylinders. And with normal disk geometries, that will limit you to disks of 500 gigabyte maximum. There is a way around that more or less by using non-standard geometries with a huge number of heads over the normal limit of 63. And you can bump it up to either 127 or 255, and that will allow you to use disks to 1 terabyte or 2 terabyte. That's typically.
But that only works on partitions that have LVM data. You know, remember that's where that stuff
well,
is
yeah,
stored.
if you want to use them with
yes.
But at least that will allow you to see that whole 2 terabyte from Ecom Station.
By LVM, you mean that special type?
You get the DLAT.
No.
Technically, it's the DLAT sector where that stuff goes.
No, not the special type.
Not the special.
Just the additional information.
Okay, all right.
Yeah.
So that would be basically on OS2, that would be any partition, HDFS, JFS, as long as then, because everything is managed by, or
Yeah.
everything has LVM info.
Yeah. What it does is make sure that even if you are at the end of the 2 terabyte disk, the cylinder number will still be below 64K. Yes?
Isn't it also true that the only way to get that information on there is to start with a pristine disk and let us be the first thing to see it?
Well, you could add the information later, but if you have created partitions already using a geometry with 63 heads, then they will be aligned to that geometry. So it's not really possible then to change that. Well, you could change it and create new partitions and then rewrite the geometry and all the LVM information, and it will still work. But then you got some sort of a mix of old and new geometry, which will lead to warnings. It will probably work, but it's not complete. So the best way is to start out with an empty disk and make sure that all the partitions are aligned to that geometry you want to use.
And what allows you to put in that information, to change the CHS?
Well, if you start with a really empty disk, then the normal Ecom Station installation tools will handle it for you. So LVM and mini LVM will actually, comes out of the DFSee drivers, actually, the LVM stuff. That will automatically...
What you need for the traditional LVM that is a little more complicated than that.
Yeah.
The best way to do it, I recommend you just describe the way to do it correctly in DFSee.
Yeah, you can do that, but let's put it this way. If you don't have DFSee, if you have an empty disk, then just installing Ecom Station or using that disk with Ecom Station will also take care of it.
Because mini LVM has basically the same algorithms that DFSee does.
Yeah, exactly.
For obvious reasons.
Yeah.
And then if it's bigger than 2 terabytes, you just can't use the remaining part of the disk.
No. If it's larger than 2 terabyte, you're going to need sector numbers that go beyond 2 bits. And the classic MBR style partitioning will not allow that. That's one of the reasons you want to use GPT, because that has 64 bit sector numbering. And you can go beyond the 2 terabyte limit. So what you do with DFSee, and actually, well, the mini LVM does the same. Actually, you create your first partition, and it will put LVM information on that. And because it already uses the correct geometry, DFSee will do it automatically if the disk driver presents it with that geometry, which the later stuff will do automatically on large disks. If not, you can force it in DFSee. You can set the geometry manually, the command or from the menu. And then that will get recorded into the LVM information that's written to the disk. And from that point on, DFSee will automatically retrieve that and use it.
Don't you actually look at the disk size? Don't you look at the disk size? Because if there's existing partitions, we can mix and match. That's not a problem. You get warnings, but it will all work right. The DMD will handle
it will still work.
But you won't be able to create partitions above the 512 gigabyte limit unless you use the large geometry.
Yeah, that's another possibility. What I did on, I got a ThinkPad with a 1 terabyte disk, and I had the choice. What will I do? Will I use it as a 1 terabyte with this special geometry, or will it just use, because Windows was installed in there, of course, and what else? So I decided to restrict EqualStation to the first 500 gigabytes. So I just used the classic geometry with 63 sectors per track, and that works. But EqualStation will not be able to address anything over 500 gigabytes, which is fine by me because I've got a large Windows data partition beyond that, and 500 gigs is more than me for EqualStation. So no problem. Okay. Wow, it's really, because CSS is limited, you have to use dummy values if they don't fit, and there's a few different standards for how to do that. Some tools will complain if you use the wrong standard.
It's also good to know the hex values so you can tell if other partitioning tools have been in there.
Yeah.
We're going to always look for, in our case, we want FFFF, if I recall.
Yeah, it's Microsoft.
Yeah.
Yeah.
And if it's something else for the Macs and it's big, you should probably do some repairs first before you start partitioning.
Okay, let's move on to the GPT. GUI ID, partition tables. GUI ID is unique identification, which is a long string, actually just numbers. It's used in lots of places in all sorts of software. And in here it's used for two things. One is to uniquely identify each partition, so those things are created on the fly when you create partitions. And the other ones is there's a GUI ID as well for each partition type. So instead of a single byte, like 07 or 35, whatever partition type, there's now a GUI ID string to describe lots of standard partition things. You can go over the 2 terabyte limit because they use 64-bit sector numbers, physical sector numbers, PSN. And they're usually embedded in an MBR style guard partition with a special type of EE. And currently you can display GPT stuff, you cannot modify it. Okay, there's GPT information consists of two parts. There's a header that describes how large the actual array of information is, and there's some other administrative stuff in there. And there's a partition table array information, and that stuff is duplicated at the end of the disk. And in the header there's information on the position of where this partition table array is located and how large it is and stuff like that. There's another GUID there for the whole disk, so each disk also has a unique identification. And also there are checksums and stuff like that in there.
Neil's the one you should talk to.
So this is what it looks like. The disk is using it. There will be an MVR, and it's defining the guard partition. That's the whole remainder of the disk. And that remainder area will have an area at the beginning and at the end that describes the GPT partitions.
How can you have an MTR defining the entire disk if it's larger than 2 terabytes?
Oh, you can't. It will probably max out. I've never really looked at that, but yeah.
I'm sure it's a
probably
2
just max
terabyte
out.
max. Yeah.
Okay.
You know, the thing is only there to prevent other partitioning tools that you got a disk, you plug it in, it's GPT, and the other tool will say, okay, I don't see an MVR, the disk is empty, let's partition it. That's why the guard
So
partition is there.
if it was 2 terabytes, the other tool would...
Yeah, it's just.
Yeah, like you said, okay, there's 2 terabytes and it's all used, so there's nothing I can do.
Yeah, it just looks like it's.
That's what it's for.
Yeah, okay.
It's just,
So it still works even for its intended purpose, even if it is a 3 terabyte disk. It's
yeah,
prevent-
exactly. It still prevents it from modifying. From actually prevent it from thinking the disk is empty.
Yeah.
That's the same problem you used to have with all Macintosh disks that had some kind of partitioning on it, and DOS-style partitioning tools wouldn't see that and say, okay, that's an empty disk, let's use it. But it was full of bank partitions, but this is described in another format. Okay, that's what it looks like. So they're more or less comparable to primary partitions in the MVR style. I mean, all GPT partitions are created equally, more or less. There is no logical partitions in GPT. Okay, questions on that? How long have we got? Another?
We have 2 minutes, 2.5 minutes.
Well, the second part would have been something about file systems, but all the presentations are up on the website. There will be shortly, they're on my own website. So we won't be able to get to that. I'll just quickly show some of the stuff in DFSee itself. So that's...
No question, it's more than spurring this proposal.